Hi friends!
Chemical process and chemical processing. These two terms are at the heart of most of what chemical engineers do. Now, let us see in detail the different types of chemical processes and the diagrams we use to produce many different intermediate products and the final products. The second chapter, role of chemical processing. The contents of this chapters are what is chemical process, process categories, and chemical process using process diagrams. What is chemical process? It is a combination of steps in which starting materials or the feeds here A and B are converted into desired products or the final products C. Now, let us see how this reaction is taking place in laboratories and in automated implanted plants. In laboratories, chemical A is poured in a test tube and B into another test tube. Both are then heated over a laboratory burner or heater. Now, both are reacted to form chemical C. Finally, the produced chemical C might have some unwanted materials. It is then separated by boiling it off from the mixture or allowing it to settle down to the bottom of the flask. And here the reaction is taking place in the reaction flask. In automated implanted plants, chemical A is pumped from tank A through a pipeline containing a heat exchanger. Similarly, chemical B is also pumped from another tank B through another heat exchanger. Now, these two reactant streams are then sent to a reactor with the temperature, pressure, and catalyst needed. Now, the product mixture is sent to the continuous distillation unit to separate C from any unwanted chemicals in the stream. As you can see here, heat transfer, chemical reaction engineering, and mass transfer, everything is happening. Different categories of processes are batch, continuous, steady state, or unsteady state. In a batch reactor, materials are loaded into the reactor and the reaction takes place there. And the final materials are removed and this steps is repeated. Whereas in a continuous process, materials continuously flows in and out of the reactor. While the reaction proceeds as the material moves through the reactor, there is no interrupt in the flow and the reaction. In a steady state, process characteristics does not change with time, whereas in unsteady state, process characteristics does change with time. Chemical processes using process diagrams. What are the different diagrams we use? Block flow diagram, process flow diagram, piping and instrumentational diagram. Block diagram or BFD. It's a simple representation of any chemical process where block or box is used to represent any equipments used in the process. Here it shows an example of a chemical plant for making nitric acid. Process flow diagram or PFD. It provides more details than BFD. Here the figure shows PFD for the same nitric acid plant showed in BFD. Here, data for the streams are compiled in the stream table at the bottom of the flow sheet. Process and instrumentational diagram or P&ID. It provides even greater details than PFDs. All streams and utility lines entering and leaving the diagrams are identified here. Example of small portion of such diagram is shown here. So hopefully we are done with the chapter 2. Now in our next video we will be coming with the chapter 3 where we talk about the strategies. Which are strategies we have to look into and how can we solve any problems. Until then, bye-bye.